Okay, thank you for joining me today for Dan Hotka's Lunch and Learn, short webinar topics on Oracle things. We're going to wrap up the SQL tuning month. It is well into December, but there is no real format for these anyway. And second, I just had a little bit more content that I wanted to share with you. So this is my short disclaimer. Okay, I am an Oracle ACE director. This is my method for sharing my information and background and knowledge with you folks out in the Oracle community. That's what we ACE directors are supposed to do. So I am well authored. My experience with Oracle products goes back like 28 years. You can register and get the link sent to you Monday morning. Just go to my website and click on register for the announcements. I do regularly blog, and I am a regular trainer. So I've got some classes coming up. I'm going to talk about those shortly, but basically it's one fee on-site over the web, and when I'm on-site I have my own computer lab. Content today is out of my SQL tuning class. Content for this past month has pretty much been out of my SQL tuning class as well. So want to know how to fix all these SQL problems that you're having? Have me on site. So we are wrapping up the Explain Plan series, and I'm just going to go over some problem SQL today. I have been approached by a good client to do a public offering. He's got just a few people for the class, so I should already have the minimum that I need to run these 3 classes. I'm going to try and run them in January. Intro to Oracle, okay, 2-day class on Intro to PL SQL. And 4 or 5 half days, we're going to do this in a half-day format, 5 half days for advanced PL SQL tips and techniques. By the way, this could easily be renamed New Features for Developers. Okay, today's topic is I'm going to review Problem SQL. Again, these topics have come out of my SQL Tuning class for developers, my SQL Tuning for Developers class. Okay. One of the things that I've talked about, not really so much in this class, we've been covering various things, is there's some commonalities with problem SQL, okay? Not always, but usually the few SQL statements that slip through the optimizer, they do not get a good explain plan, have some common attributes about them or things that I've noticed over the years. The first one that I like to point out is, and one of the things that I harp on throughout the class, is you eliminate most of the rows first. You want to find the driving table. You've got multiple tables on the join clause. Or if it's a single table access, you still want to eliminate most of the rows on the innermost step of the explain plan. Okay? So you want to eliminate most of the rows first. If you don't do that, there's a faster option. Okay? Nested loops. Nested loops, when you do a join, you always join 2 tables at a time, okay? I'm not giving away the farm too much because the class talks about how to fix these things, okay? Nested loops, if they should go, the outer table or the first table in the nested loop should be the larger of the 2, larger in terms of the where clause predicates, okay? And the smaller should be quite small, or have like a unique index access, because unique always makes 1. Remember that from a couple weeks ago when we were talking about explain plan content? At any rate, larger to smaller. Hash joins should go smaller to larger, and if they happen to go larger to smaller, they're not as efficient, i.e. there will be a performance issue with either of these if a nested loop goes smaller to larger or a hash join goes larger to smaller, okay? Merge join, if a merge join appears, I always investigate because honestly, I have had good luck using the use underbar NL hint, use nested loop. Put that hint in to get it to do a nested loop. I've had really good performance gains changing merge joins to nested loops. I've really not had or seen a lot of success changing nested loops to hash joints or hash joins to nested loops. Now, Oracle 12 is going to address some of these issues. They're going to try to programmatically, and it's called adaptive SQL plans. They're going to change plans on the fly when they see real row counts that kind of fall into these patterns. We'll see how well it works for them. A lot of us won't be to Oracle 12 for quite a while. And if Oracle doesn't deem the SQL adaptable, it won't make any changes in it anyway. So, with that said, let's look at some problem SQL. The first one uses this Teams Manager and Master public domain database. I like to use this in the class for the bigger queries. And we got a lot of questions in here. And honestly, just to give you, make this quick work, this line here is the one that eliminates most of the rows, this in clause off of Teams. If we look down at the explain plan, there's our innermost hash join. We're looking at a Toad one here. And Toad nicely numbers the steps for us. But there's our innermost hash join, the first table being accessed. That's our driving table, which is the Teams, okay? And then we're doing a full scan against the managers table, which may or may not result in an index, okay? I think there's 2,300 rows in there, so maybe that's okay, okay? So at any rate, this basically muddles around here with this little bit of numbers, okay? It comes out of there, and again, hash join, remember, goes smaller to larger. It did, in fact, go smaller to larger. Comes out of there, and I'm just going to use the Oracle terminology, with what it thinks. Cardinality is estimated, and I'm going to talk about actual row counts here in a moment. It comes out of that hash join with what it thinks is going to be 89 rows. This becomes the in table, gets passed up to the next hash join. This becomes the outer table to the next one, and it goes smaller to larger again. The problem with this particular query is now it's going after and doing row elimination out of the vast amount of rows, coming up with 357 rows out of that, okay? This query actually works better when you get the master table, you get some of this row elimination here, you get some of this row elimination on the first step. This one actually goes a lot better because what happens is you pare down this to, I think, a couple of thousand rows, and then you're taking one of these other ones against a couple of thousand rows, not 61,000 rows. So it actually works better when you eliminate most of the rows on the innermost step. Okay, next query. And this is something that I see quite a bit, and this is why we ran trace in yesteryear. Oracle 10 has introduced us, and I think I've shown this in a Lunch and Learn, but I'm going to show it to you again. Okay, when you look at an explain plan, because you asked for one, you're in Toad, you're in SQL Developer, you're in any of the tools, you click the Explain Plan button, gives you an Explain Plan. It's this column. It's the cost-based estimate based on statistics that it used for that to assemble that Explain Plan. What you really need with problem queries, and this is why we ran Oracle Trace for years and years and years. And by the way, I have got scripts that will run Oracle Trace, turn it on, run your SQL statement, turn it off, show you the output. Okay, not going to really talk about that too much here, but I do have those scripts if you're so interested. Okay, but what has come out of Oracle 10 is this ability. You add this hint, okay, add this hint, run the explain plan, and then you run a DBMS explain plan output, and it will give us the actual row counts versus the estimate. And what we can see here is on the estimate, if we just look at this query performed poorly. It's another Masters, Managers, Teams. This one performed poorly, okay? And the cost-based estimates, again, hash join. We go smaller to larger. That looks okay. And we come out of that with 6680, goes down to this one. And that looks pretty good, okay? Smaller to larger again. But in actuality, there was considerably more rows there. Now, when you look at these explain plans, would this have produced a different explain plan? Well, probably not with this one, okay? It did go small to larger, considerably more rows. Okay? The problem is it came out of this one with 94,000 rows, not 6,600 rows. Okay? Considerably more rows. And it went larger to smaller, not smaller to larger on a hash join. Okay? So it's processing considerably more rows. Now, again, Oracle 11 addresses this a little bit. Oracle 12, this is that adaptive SQL plan management that Oracle's working with in Oracle 12. Might address this, might not. This is probably one it would probably address. But at any rate, you need the actual row count with problem query, and you get actual row counts with either running a SQL trace or you run this DBMSX plan syntax. Okay? Now, my JS Tuner, just a plug for my free tool, and you have to ask for this, my JS Tuner console, I run that DBMSX plan syntax behind the scenes for you. So you don't have to worry about running that. So at any rate, you can see here we've got the same explain plan, shows up nicely in my tool, and I've got this tool updated for Oracle 12. It does some of the newer Oracle 12 DBMSX plans things as well. It has some indexing buttons at the bottom. I give you a lot of useful index information. It's like I say, it was a tool that I came up with before SQL Developer to run explain plans, and it has evolved into a launch point for the newer Oracle DBMSX plan type syntax that's available. Okay, the next SQL statement that I want to look at, this came out of Oracle Financials, has an ordered hint in it, and it only has one table. Now this is an Oracle 9 one, okay, but I like that. There's a couple of things I like to point out in this one. First off, it's got a ton of subqueries. It's got a ton of inline views and subqueries, 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 subqueries. It's just full of subqueries. Oracle 10 has introduced this QB name. By the way, Oracle 10, big change for the optimizer. Lots of good things happen with Oracle 10, and they continue on with 11 and 12. So anyway, Oracle 10 introduced this QB name where we can give the subqueries a label. Toad exposes it, my JS Tuner exposes it, and RapidSQL exposes this column in their explain plans. So you can give the subqueries a label. Okay, and they'll show up in the explain plan nicely. Okay, looking at this particular one though, we've got some subqueries. We've got this nasty OR in here that might be resolved by coding this into a union clause. Don't know. And we look at the explain plan, and it's the older style auto trace, but I like these numbers because these numbers, this is the parent ID, this column here is the parent ID, and the output of this step goes to this step. Okay, so when you get these explain plans that indent out and then indent and again, what is the driving table? This one you can kind of see from the indentation that it's this at step 9, but you also trace all of these back. Okay, you trace these up. The output of this goes to, the 10 goes to 9, 9 goes to 8, 8 goes to 7. They all end up at 3, this filter operation, which is kind of interesting because it takes 3 row sets in and merges them together, so it's capable of doing more than 2 things. But at any rate, you come down here, and if you look at the cardinality numbers, it's really not dealing with a lot of rows. Okay, the cardinality is really low on these, stuff like that. The thing that I don't like about this particular SQL statement is this comment right here. I want to comment on this for a moment. Whenever you say row num less than or equal to this, what if this thing returned 1,000,000 rows and you only wanted 10,000 of them? You've asked Oracle to do an incredible amount of work, and you're going to throw most of it away. This is close to, I have the same comments on the having clause. If you're using a having clause with a group by, it works with group by, but it works standalone too. Basically having, you return a row set, and then you'll filter based on the contents of the row set. Where clauses do row elimination, having clauses throw rows out after they've been selected. okay? And even a group by clause. If you can do a better where clause so that you don't have to either use a having clause or it greatly whittles down what the having clause is going to throw out, use that, okay? So this problem query, I forget what the exact issue was with this one, but I really wanted to show this one to talk about the issues with row num. Now, the other side of the coin is you want to see some data real quick on this huge table. You say, well, row num equals 1 or row num less than 10. Oracle knows to go to the front of the object, read the first block or two, and pull the rows off of it. So the upside is you can use this to your advantage if you just want to see some data. And, you know, you don't want to use Toad or SQL Developer because they're going to go pull way too many rows. It's going to take too long. You're afraid of doing a full table scan across the whole thing. When you just want to see some data, drop into SQL Plus or drop into either any of those tools, select star from large table where row num equals 1. And it will go read the very first block and bang, bring in the first row. There's a good tuning tip for you, or something faster. Now this next one is a parallel query, and it's kind of interesting because this person really wanted a quick fix, and they really didn't give me a lot of information that I needed to help them, other than when I see problem parallel queries, there's some common attributes again. When you get the first off, the explain plans for parallel queries are quite nice. It gives you a lot of useful information, and parallel queries typically go with partitioned objects. Not always, but typically. This happens to be a partitioned object as well. So when you're going after partitioned objects, there's two no-nos, and just keep these in mind, and you'll have a lot of luck with these. First thing is don't hang any subqueries off the partitioning key value, and second, don't put any functions on the partitioning key value. Code in such a way that you don't have to do either of those two things. Okay? So I was actually doing some consulting on site. Fixed a performance problem, a big problem they were having with this, because they just happened to be running the SQL out of PL SQL. They had a couple of functions manipulating the date field around, the date field with the partitioning key value. I was able to resolve what they wanted back to a variable, and then I used brain fart here, sorry. I used not SQL creating SQL, but I used dynamic SQL. I pasted in that variable outside of those functions and got rid of this. No longer was it doing a selection and passing. Basically what key says is at hard parse time I cannot get a clear view of the partitioning key values, so I'm going to leave it for runtime. Now at runtime it may or may not get it right. All I'm saying is whenever I've got a problem partition query, it usually has this. The other thing to take note in this particular one is, and I asked this person, well, how many partitions does it have? Because it didn't prune very well. It started with partition 1, went through partition 104. I suspect there's 104 partitions. And even if they have one partition per day, there's 365 partitions. It did not prune very well here. So a couple of things to keep in mind with partitioned objects. I see a question. Let's go out and take a look and see what the question is. Chat. Nope. Just a friend saying hi, which is very nice. Okay. Let me move this back over. Next problem query. I believe this one came from someone that was in class, and they shared this with me the following week. And again, I asked them more questions and didn't really get anything back like, what is the query? What is the query that goes with this? Okay. So we look at this, and remember what I said about nested loops and hash joins. We got a little bit of both going on here. We got a hash join. We got two nested loops. I suspect this query was either full of inline views or it was full of subqueries. And the subqueries had some nested work going in it. Maybe they had an inline view, but the subqueries had some join conditions coming in, because I would suspect that this and this where both subqueries produced a row set, and that row set came out of those subqueries and then was joined up by this hash join. Now, generally this is where I would ask the class, what's the problem with this one? Because if you look closely, and we're going to break it down here, if you look closely, you can see the problem. Okay? The view gives me an indication that this is indeed a subquery or a view. It's just joining up views, and this syntax is in each of the views, either one. So, nested loops is larger to smaller, and indeed we went larger to smaller, and down here, larger to smaller again, and there's your unique scan, that's one, that's excellent, nice use of a unique index, and a nice use of a nested loop. Okay, this nested loop produced 2,600 rows, this nested loop produced 507 rows, and we're doing a hash join. Okay, it's going larger to smaller, folks. That's the problem with this one. How do you solve this one? I think this one lends itself for the leading or the ordered hint, which says take the tables and the subqueries. The ordered hint would probably work a little better if they're calling views or making reference to subqueries. It says take the items in the order that they appear in this query and process them that way. Don't be, in your permutations, don't be mixing everything up like you normally do, but take them in the order that they appear in, and then put them in the right order so that you get that this view is referenced second and this view is referenced first. That should reverse these two and get this thing to running better. Okay, everybody see that? You go nested loops is larger to smaller, and this did, and hash joins is smaller to larger, but this one went larger to smaller. Okay? So, we've talked about a few problem queries. I gave you an indication of what to look for in a performance issue to look at with their explain plan. The slides and the link to this presentation is going to be up on my website probably after 2 p.m. I am going to add the DBMS the DBMS X-Plan syntax that I have embedded. I want to show you that syntax. Do let people know about these lunch and learns. Remember me when you have a training need.